just now as I said you that here either in the topics curve fitting or in correlation you are going to consider the two variables which is called a bivariate data. So whenever some data is given to you, always it represents a curve, not exactly, it may represent a straight line or a linear form or non-linear form. So by looking on this only, we cannot say it represents a straight line, it represents a quadratic equation or anything. Every time we cannot plot on the graph to identify which curve it represents. Are you getting? Whenever a bivariate data is given to you, it always closely represents a curve. That curve may be a linear or non-linear form. By looking at the data itself, you cannot decide whether it represents a straight line or any other line or any other curve. Now, to check that if you want to fit you can fit a straight line. What are the different forms the data can represent? Means it can represent a straight line. It may represent a quadratic equation or parabola, or exponential curves, or power curve. The data may represent either of these. Maybe the data may represent a straight line, the data may represent a parabola, the data may represent an exponential form, or it may represent a power curve. Now, how to fit means you should how to fit a curve to the given data means you should make use of principle of least squares. Girls, listen. Even though it's the terminology or the derivation may be a little bit different when compared to the previous semester, try to understand the first fit. If you can understand the fitting of straight line, okay, the remaining all are nothing but similar to it. Means try to focus on the first fitting, curve fitting, so that the remaining will be easy to you. One more thing, when compared to your Sem 2, Sem 3 syllabus is less. I think you know that how lengthy the Sem 2 paper is. Sem 3 paper when compared to your Sem 2, Sem 3 is only half of it. Means you can finish syllabus as early as possible. Even in learning also it's a easy one when compared to the Sem 2 paper. Now let us say how to use this principle of least squares to fit any curve to it. Here principle of least squares tells that what do you mean by error? How do you define in general error? As the difference of actual value and estimated value. For suppose that if I say that after attempting an examination, out of 100 marks I am expecting 86 marks. Means this is my estimation regarding my attempt. So out of 100 I am expecting 86 marks. Means this is my estimated value. But after once the results are released, I got the actual marks are nothing but I came to know this as 75. So what is the error there? Error we define as what is the actual value you got? 75 minus 86. I think you'll get a numerical value around 9 or 11. So error means it may be a plus or with a magnitude plus or minus. Error, how do you define in general? The difference of actual value minus estimated. Before getting the actual values, always you will have prediction. What is the chance that you will get? What is the chance of raining? So you'll have somewhat like there is 80% chances it may rain up to 7 centimeters. There is an expected rainfall. But after the particular time we have observed 10 centimeters of rainfall. What is the error there? The error is nothing but 3 centimeters. Error in general, not related to statistics. Generally error we define as the difference of actual value minus estimated value. Now according to this principle of least squares, always the error should be, what is the nature? Error is to be minimized or maximized? Error is always to be minimized. According to principle or general, error is to be minimized. Now for fitting any curve, so suppose that you are given a data and they are asking to fit a straight line. So the data may represent a straight line or may not represent a straight line. So there also there is a chance of committing error there. That data actually may represent parabola, but you are fitting a straight line. Then what to do then? Then if at all, I think there is a chance of error, then error is to be minimized. Error is to, under principle of least squares, it states that error sum of squares is to be minimized. Error sum of squares is to be minimized. This is a statement of, means the technique of finding functional relationship between, these are two variables given to you. To obtain the functional relationship like straight line or anything, what is the condition according to the principle of least squares? The technique of finding functional relationship between two interrelated variables such that error sum of squares is to be minimized. So to fit a straight line or to fit a quadratic equation or an exponential curve or any other curve, we are going to make use of principle of least squares. Let us go to the fitting of straight line. If I start that, you will get a confidence. Always if I go with theory, it may not be good, girls. Let us see how to fit. What are the different curves you are going to fit is nothing but you are going to fitting of straight line is the first curve you are going to read. Fitting of straight line, fitting of parabola, fitting of exponential curves. Means here you are going to deal with two types of curves. And power curve, means under curve fitting. What is the meaning of curve fitting? Curve fitting is nothing but the technique of finding suitable mathematical curves that closely represents the given data. Again I repeat, curve fitting is nothing but the technique of finding suitable mathematical relationship between two interrelated variables that closely represents the given data is called curve fitting. To fit a particular curve to the given data, we make use of principle of least squares, which consists of minimizing the error sum of squares. Now let us these are the four fittings you are going to read. So in the examination point of view, you may get any of these four curves for 12 marks. Fit a straight line, fit a parabola, fit an exponential curve, fit a power curve. Again, you are not going to get any numerical problems in the theory paper. You will only get exclusively theory like define, write the differences, write the procedure. So what is the first procedure you are going to deal is nothing but fitting of straight line. Just now as I said you that throughout these topics we are going to consider the bivariate data. What do you mean by bivariate data? Which involves two variables. Let us suppose that the two variables under study be x comma y. In general we designate the variables with x comma y. So to fit a straight line or to obtain the fitting of straight line involves, let us see what are the major steps while writing the procedure of any curve. Now curve fitting, is it related to univariate or bivariate? As now I said you that this is only related with bivariate data. What do you mean by bivariate data? It involves two variables. Let us say that the two variables under study be x comma y. What I said, one more point, always will have paired data. What do you mean by pairing? Equal number of observations on x comma y. Means if we are given with 10 observations on x, so the corresponding 10 observations are also there in y column also. So here let x comma y be the data collected on two variables x comma y. Now which curve, now you, after specifying this, you should write which curve we are going to fit. We are going to fit the straight line. So always we'll write the dependent variable on the left hand side. So among the variables x comma y, we consider this as the dependent variable. What is the straight line form? In general, y is equal to mx plus c. I think this is a straight line. Y is equal to mx plus c with m as the slope. Similarly, let us take that as a plus bx. Let the curve, as we are fitting the straight line, that y is equal to a plus bx be the curve to be fitted for the given data. Now, what are y comma x? Y comma x are just as we said that these two are the variables. What are the two constants here? Specify those two constants. You will know what is the purpose of writing this afterwards. Now, we are fitting a straight line. So, you have described the data. How you have described? You are going to consider a bivariate data called x comma yi on n variables, and y is equal to a plus bx with the straight line to be fitted for the given data. So, what are the two variables here? X comma y. What are the two constants here? A comma b. Now, these two are variables. Now, your job is nothing but you should find out these two values a comma b are unknown constants. Now, to fit this line, you should find out the values of a comma b. This is a procedure, not numerical problem. Let us discuss the procedure first, followed by the problem. Here you have two constants a comma b. Now, fitting of any line involves, we are going to make use of the principle called principle of least squares. Principle of least squares. What does this principle of least squares tells? That sum of squares of error is to be minimized. So again I am repeating. Now we are going to look at the topic called fitting of straight line. To fit the straight line, you should consider the bivariate data. We represent the bivariate data in this way: xi comma yi, I is equal to 1 to n. There are n number of observations on both x and y. Which line you are fitting? Straight line. We know that general form is mx plus c. In the same one, I am writing with the changing constants y is equal to a plus bx. Here x and y are the variables, a and b are the unknown constants. So if you want to fit the straight line, you should find out these two constants a comma b. So how to find out these a comma b means you on all the curve fitting make uses of a principle called principle of least squares. What does this principle of least squares tells? That error is to be minimized. Instead of minimizing error, we are going to minimize the sum of squares of errors. Now y is equal to a plus bx. Now let us define error first. How do you define error? As actual value minus estimated value is called error. Now let us write the actual value with y, and what is the curve we are fitting? A plus bx. So write down whatever curve we are fitting, write down that. This is nothing but the error. Actual, let y be the actual value. What is the curve you are fitting? That becomes the estimated value here. So as you have n number of observations, let us add a suffix I to both the variables here, a minus a plus bx. This is simply error. Here what is to be minimized? Sum of squares of error. Not simply error, you should minimize sum of squares of error, means sum of squares is missing here. Let us write s as the sum of squares of error. Then s will be, sum means we denote with sigma. Okay, squares. What is square here? Square means write down square here. S denotes sum of squares. Sum I am writing with sigma squares. Here you should take the error. Let S denotes the sum of squares of error. Then sum squares of error. How we are defining error as? Error as nothing but actual value minus estimated value, which is nothing but y minus a plus bxi. Now this S becomes, S is equal to sigma sum I is equal to 1 to n yi minus a plus bxi whole square. This is to find out these unknown constants. To find out a comma b, we use principle of least squares, which we write as PLI, principle of least squares. So what does principle of least squares tells that S, the sum of squares is to be minimized. As you know that minimizing a function means maxima, minima. In mathematics also we did in the first year also. Maximizing means or minimization, you should find out the partial derivatives and equate it to 0. Am I right? Maximizing or minimizing involves finding the partial derivatives and equating them to 0. Now, how many constants are there? We have two constants. What are the two constants? A comma b. Now, if you want to find out a comma b, your s should be minimized with respect to a ones and with respect to b ones. Again, I am repeating. To find out the unknown constants a comma b, you should minimize s with respect to a ones and with respect to b ones. That is, you should find out dou s by dou a is equals to 0. What is the other constant? Dou s by dou b is equal to 0. Now dou s by dou a means, here you have it is in the derivative x square, which we 2 into x. What is the derivative of x square? It is 2x. So 2 sigma yi minus a plus bxi into what is the inner derivative of this function yi minus a plus bxi. This is 2 sigma yi minus a plus bxi. What is the inner derivative or partial derivative of it that we are differentiating with respect to a partially, except a, all other are treated as zeros. So what is the derivative of yi with respect to a? 0. What is the derivative of minus a with respect to a? Minus 1. What is the derivative of bxa? As it is independent of a, you are going to get 0. So you got, if it comes to here, this will be minus 2 yi minus a minus bxi. Okay, so as you are minimizing it, dou s a dou a should be equal to 0, which implies minus 2 sigma yi minus a minus bxi is equal to 0. You have equated that to 0. Let us simplify this. As if you have a dot b is equal to 0, what does it mean? Either a is equal to 0 or b is equal to 0 or both a and b is equal to 0. Generally, you have minus 2 into this term is equal to 0. Means either this should be 0 or this should be 0, which implies sigma yi minus a minus bxi is equal to 0. Let us take the sigma to each and every term. Sigma yi minus sigma a minus sigma bxi is equal to 0. I think you know always sigma runs on I. Sigma yi you will get as it is. As it is independent of I, you will get this as an. Okay, if you take out this a, sigma 1 will be an. If you take out b here, b sigma xi is equal to 0. So let us shift these two to the RHS. Sigma yi is equal to an plus b sigma xi. This is the first equation you got when you have differentiated with respect to a. The same s, what is s here? S is nothing but sum of squares of error sum of squares, which is nothing but s is equal to sigma yi minus. Now, as you have two constants, you have minimized with respect to a. Now we are going to minimize with respect to b and equate that to 0. That is, how much you will get? 2 times. Again, it is in the form of x square. Sigma yi minus a plus bxi into inner derivative of the same, that is sigma yi minus a plus bxi. This is 2 sigma yi minus a minus bxi into what is the derivative of the first term? As you are differentiating partially, all other terms are considered as 0. Its derivative will be 0. A with respect to b is a constant, its derivative is 0. Here you have minus sign here, minus. B derivative is 1, you will get here xi. You have, what is the term here? It is independent of b 0, independent of b 0. Here you have bxi. As you are differentiating with respect to b derivative will be 1, you will get minus xi. Again, take this minus here, minus 2 sigma yi minus a minus bxi into xi. So minus 2, let us multiply this xi yi minus axi minus bxi square. So I hope dou s by dou b should be equated to 0. That is, you will get minus 2 sigma xi yi minus axi minus bxi square is 0. So you will get sigma xi yi minus axi minus bxi square is equal to 0. Let us take this sigma to each and every term. As you know that a is independent of I, sigma always runs on I. So this a can be taken out of the sigma, b can be taken out of the sigma. Shift these two terms to the RHS. You will get sigma xi yi is equal to a sigma xi plus b sigma xi square. How many constants you have in the given equation? Y is equal to a plus bx. You have two constants. So you have differentiated s with respect to a once and equated it to 0. You got one equation. You have differentiated s with respect to b. You got another equations. These two equations are called normal equations. We call those as normal equations. Now, let us write those two normal equations together. So, by differentiating with respect to A, you got this equation. By differentiating with respect to B, you got this as another equation. What is your main purpose here? You are fitting a straight line. In fitting of straight, what is the form of straight line you have considered? Y is equal to A plus bx. What are the two constants there? A comma b. Now in the beginning I said you need to find out a comma b. To find out a comma b, we are using principle of least squares, which consists of minimizing error sum of squares. Minimizing error sum of squares means how many, you should check how many constants are there in the given equation. Here you have two constants a comma b. Those a b can be calculated by minimizing s with respect to a ones and s with respect to b ones. So you just now we saw the procedure. By differentiating with respect to a, we got this equation. By differentiating with respect to b and equating to this, we got another equation. So we have two variables and two constants. So here while doing the practical problem, we'll understand sigma yi. What do you mean by sigma yi? Total of yi means when you are given with xy data will be given to you. I think 1, 2, 3, this is the data given to you. Sigma yi means this total, this is a number here, n is the number of observations. Sigma xi means by adding this column you will calculate. Sigma xi yi means you will find out xi yi and you will get another value here, sigma xi square. Means whatever summations you have like sigma yi, sigma xi, sigma xi yi, sigma xi square or the totals, those can be calculated from the given data and are substituted, and you can solve these two equations to calculate a comma b values. After finding these two values, you will substitute in the given equation. You will get like with let a cap comma b cap be the estimated values, means this will be the straight line to be fitted for the given data. Girls, listen once again. I will repeat the same again at a glance. Now under curve fitting, you are going to discuss fitting of straight line, fitting of parabola, fitting of straight line, parabola, exponential curves and power curve. So if you can understand this, all these are similar. So fitting of straight line or any other curve involves principle of least squares. what does this principle of least squares tells? That generally error is a quantity which is considered as the difference of actual comma estimated value. Under principle of least squares, error is always to be minimized, or error principle of least squares tells that for a curve to be a best fit, for a curve to be the best fit for the given data, the error sum of squares is to be minimized. Okay, for a curve, if you say that for the given data straight line is the best curve, then error is to be minimized, or it should obey the principle of least squares. Let us start with fitting of straight line. So all this deals with bivariate data. Let xi comma yi be the bivariate data, and let the curve to be fitted be, if it is a straight line, y is equal to a plus bx. If it straight line form is this, as you know. Parabola means y is equal to a plus bx plus cx square, second degree equation. Exponential means y is equal to a e power bx, y is equal to a b power x. This is y is equal to a x power b. These are the different forms you should by heart: straight line, parabola, exponential curve and power curve. First specify the curve which you are going to fit. This is the curve we are going to fit. Here x and y are the variable, a comma b are the constants. Now you should find out these two constants. How do you find these two constants? These two constants are calculated by using the principle of least squares. What is the principle of least squares tells that the sum of squares of errors to be minimized. How do you define the sum of squares of error? Before defining the sum of squares of error, let us define the error first. Error is nothing but difference of actual minus estimated value. Let us write the actual value with y, and estimated means if it is the straight line fitted means this will be the estimated value. If you are fitting a parabola, this will be y minus a plus bx plus cx square. Now error is nothing but, as you have n number of observations, let us attach the suffix I to the variables yi minus a plus bx. What is the principle of least square states? Sum of squares of error is to be minimized. Sum means we use the symbol sigma. Squares, put the square first. Sum of squares of error is to be minimized. So sum of squares of error. In place of error you substitute this quantity. So S becomes, S is equal to sigma yi minus a plus bxi whole square. Now what is your job here? You should find out a comma b that represents the given straight line. To calculate this, to find out these two values, we use PLI, which is called principle of least squares. S should be minimized. How many constants you have? Two constants, a comma b. So you should differentiate with respect to a, equate it to 0. Differentiate with respect to b and equate it to 0. You will get two equations. Those two equations are called normal equations. By solving the normal equations, you will get a comma b. Okay, to find out a comma b, we use PLI. Under PLI, as you have two constants, you can get two equations by differentiating with respect to a and equating it to 0. By differentiating with respect to b and equating it to 0. This is a mathematical simplification. Just you go through this. So after differentiating with respect to a partially and equate it to 0, I got one equation. Similarly, by differentiating with respect to b and equating it to 0, I got another equation. These two equations are called normal equations. Then these two equations are solved to obtain a comma b. Once those two are obtained, this represents the best fit to the given data. Okay, so this is the procedure. Procedure is very much important. So this procedure is important. In the next class I will tell you how to write the normal equations simply, and let us solve a problem also, numerical problems. You will understand in a better way. Okay, okay girls.